Guys, sorry I wasn't in class today. I wanted to sleep in and see if I can knock this out because I've been sick for a minute. But EOC review, we don't want to miss it. And if you were looking for those 3 attendances in a row for 10 points, here you go, friends. So these are function questions, and we're going to get through as many as 30 minutes will give us, because that would have been about how long I would have kept you this morning. The function f of x equals 3 absolute value x is transformed. So transformations, as soon as you're thinking transformations, looking at absolute value function, remember that's ax minus h plus k, whether it be quadratic or all the fun things, x is going to be in the parentheses or in the absolute value bar. Remember, h is going to be a right-left move. K is going to be an up-down move. My call out to EOC questions is they don't have to use H and K. They can use any variable they want. So don't get those too hard embedded in your brain. But know that if it's inside the absolute value bars or inside the parentheses with the X, it's sliding it right and left. If it's outside by addition or subtraction, it's sliding it up and down. Definitely look for a couple of these. You will see them on the EOC. So as we continue to read, the function g of x, which is given in the table, is f(x) plus k, where k is a constant, and g of x is shown in the table here. That means that is in the parentheses with the x. So that's just like being in the absolute value bars with the x. There's a couple ways you can go about this. I think the easiest way, if you remember correctly, is I would go to Desmos. So I'm going to slide over here to Desmos. I already did it to save us a little time to get through a couple more questions. And we'll hide some of it. So I would put the table in of the new function that you need, which would be here, that -2 that was given on the worksheet and the EOC question. Then from here, we know we want an absolute value equation, and we're adding something. And here I just put B out of habit, and A, again, out of habit. The variables don't matter. Again, this could be H, because that's what we're used to. I did put plus H because I want to know how that's the equation they're looking for. Instead of, normally it would be, if we're looking for transformations, remember it's a minus. But the equation they're looking for from this table is A x sub 1 of 1, which would be these x values. That would give me the output when we add B inside the absolute value bars. We've never done this in class. We've actually normally just stopped with the ax sub 1 and getting the generic, if there was not a plus B to it. That's plus K part in the question lets you know it has to have a plus thing here. Again, so talking about to the letters, it says plus K, it's inside the parentheses. We're used to plus H. I'm using plus B, all the same. So it says the equation is going to be 3 absolute value x plus 5. So the actual answer is indeed a positive 5. When you graph it, you can see it slid over, and you can compare your tables as well. This is where we started, and we want it to become this. But turned into this. You can get your table here and look for you want the same output. The input changed, the x value changed. I don't know that I think that necessarily here it makes as much sense to think about it that way. I definitely think this is the easiest way to get there. But if you wanted to test it, we could go get our table for the original function. And we know that when the output is 12, if we add 5 to -1, that means we would have, at 4, we should have a 12 output. We do. So back to your your original table, if we're looking for 18, this is saying I'm going to add 5 to the x value, and the output should still be 18. So add 5 to 1 is going to give me 6. So if I test that point, 6, that does indeed give me 18. And so far and so far. You can keep going down and check if you want. Again, this should work as long as you plug it in, and should be something you can bank on. Just depends on how much you want validation of those answers. So our answer is going to be B for this guy. Number 2, the function f of x is 3 of x raised to the third power is translated. So again, we're doing a lot of transformations. Up 4, that's definitely going to be a plus 4, and to the left 1. Moving it to the left, it's going to be a -1. We're to the third power, so again, this is a x minus h to the third power plus k, or whatever letters you want to put there. Again, don't harp too much on what letter. It's more the placement. The left rights are going to be in the parentheses. The up down is going to be on the outside by addition or subtraction, depending on if it's up or down. In this case, it is up. So a safe bet is this has to be that plus 4. So we can get rid of this guy for sure, because that's a plus 1 on the end. And we can get rid of D on the end because that's a plus 1 on the end. If that is all you know, you are now at a 50-50 shot at guessing correctly. So it's better than nothing if that's all you can get to. I've spent all day and all week with our Math 1 guys reminding them knowing something is still better than just throwing a dart at 4. You have a 25% chance of guessing it right if you throw it 4. If you can get rid of any of them, your odds are just better. And you know way more than you give yourself credit for 9 out of 10 times. So then we are going to put, we know this is a 3 in the front, x minus h, which means it would be a minus 1 cubed plus 4. That minus 1 is where we get a little confused because it looks like x plus 1 when we write our final equation. But remember, when it's inside the parentheses, it's opposite of the natural direction you think it's going to go in. So our answer is going to be B. The other way you could go at this point to solidify that you had the right answer again, it won't give you the answer necessarily, but it will let you know if we're down to these two, plug this one in and plug both of these in and figure out which one went up and which one went left into Desmos. You have Desmos for every question. This is not like Math 1 and other tests. There is no calculator inactive section. So again, more transformations. We created this function from this function. Things we need to discuss. So we went from x cubed to 3x cubed minus 4. That minus 4 is definitely an up-down. It's not in parentheses with the x. So we know, again, just trying to cross off what we can, that it is going to go down 4 units. So up 4 units, A and B are off the chart, even if you're just guessing. Again, I think that's enough and fair on EOC Day for you to know. Now you got a 50-50 shot. I would go look at them in their graphs and see which one changes and how it changes. So again, I did go put these in already for us. So for a horizontal stretch, horizontal is left and right. That means if I grab this end of the graph, the red one is the original guy. If I grab the right side and I grab the left side and I'll horizontally stretch it, I'm going to pull it out, which means this guy should start to come out slower. The increase is going to be slower. That's the equivalent of a vertical compression. Pushing down from the top would widen this arm. A vertical stretch means I grab this guy and this guy each end, and I pull up and I pull down, which means it's going to be tighter in here. It's going to come up and go faster. The increase should be faster. So when I look at our blue one, it did slide down. It may be worth it to you to get rid of the minus 4 once you understand that means it just slid down, so we can compare the steepness. It definitely got skinnier or faster, more steep going up, and faster, steep going down. It did not get fatter. I always think skinny and fat, like if we're going to squish it. Not very good math terms, but it did not start to come out. So that means it would have been a compression horizontally and a stretch vertically. We did not grab it and stretch it horizontally. So from your answer choices, it's stretched horizontally or stretched vertically. Stretched vertically is what made it get skinnier. That makes it steeper. I can't reiterate enough, the steepness, and probably some of this has been in Math 1, has nothing to do with whether it's positive or negative. It's just how fast is it moving. So going up or going down is a whole nother question. It's just, is it one of those hills that you don't want to run up or you don't want to go down, I don't know, on a skateboard for the first time ever with no pads? That kind of idea. The steeper it gets, the harder things are. Up and down is a different conversation, just as a side note vocabulary. Two functions are shown below. What is the value h of 4? I feel like we've done this one because I felt like it was really ugly along the way, and maybe not, but I think we did. And it's not as hard as it looks. So h of 4 means I would go to my h of 4, which means I'm just going to plug in 4 for x. And in this function, they are using function notation of f. This means we now have to go to f of x and plug in 4. This is our f of x. So we're going to take this puppy and we're going to plug in a positive 4 in all the places there is an x. So positive 4, positive 4. Positive 4 squared is 16. Multiply that by a negative 3. You can do it by hand. You can do it all at one time. I'm always an overwriter because I don't want to make mistakes, especially on an EOC with positive, negatives, and squaring things. And this is going to give me a negative 52. That is not our final answer. They were really kind not to give you that. I will be honest, most of your EOC questions are not multiple choice though. Be careful because that negative 52 is not your answer. That is your f of x. So f of 4 is a negative 52, but h of 4 is what we're solving for, and we have to multiply that by 3. So 3 times a negative 52 is going to be a negative 156. Oh man, sorry for sniffing, guys. The function, we have x to the 4th power, all the fun things. There's a k in there. Notice when there's a k there, where k is a constant. They have zeros, so for them to be zeros, remember zeros are also roots, solutions, and x-intercepts. All those words can be used interchangeably. That means that the output is going to be 0. This graph is going to cross at -1, -4, +3, and +5. You can go in and pick one, whichever one you want. I would probably do -1 because it's the first one and it's fairly small, and plug it in for x, because we know that because it says it is a root, that it is going to equal 0. Then set it equal to 0. Solve. Plug everything in the calculator that you want to, that you can. So -1,4, make sure you're using parentheses. -3 times the -1, make sure you're using parentheses. This guy cannot go in the calculator yet. And then add 60 to these guys. And then you should get a positive 43. I hope you went and did that and tried it, because again, it's just a matter of parentheses and fun things like that. The biggest misconception is we typically get here, we get a positive 43 and we're done and we jump. In this case, you would have jumped, not accurately, but would have stumbled into the right answer. The reality is we're going to move this over, which is going to give us a -1k. Don't lose that negative. Equals a -43. Divide by -1, divide by -1, and our answer is 43. Again, this one you could go take, you could take this number and plug it in and check it. So I did that already for you as well to try to show you how getting questions wrong on the EOC is going to be, getting to the right answer might not be as easy, but you don't have, especially if it's multiple choice, to pick the wrong answer. Disregard the bottom, just a different question, but that x to the 4 minus 3x squared minus 21x squared, we think it's 43, x plus 60. Indeed, it crosses, as it says, there's a 0 at -4, -1, +3, and +5, just like the instructions said. So if it happened to be multiple choice and you didn't want to do the math, you could type in the -43 here, the -37 here, positive 37, and then again this positive 43, and look for where it crosses at the zeros they stated were solutions, that they had zeros. Remember, roots, solutions, and x-intercepts are all the same. So our answer is D, 43, and the calculator proved it for us. Looking at number 6, another function with roots. I can't reiterate enough. Again, writing polynomials and functions is definitely going to be on there. Hopefully there's only one. Maybe there's going to be 2 to 3. Polynomials is a huge unit. I know there's a question along the way as what to focus on. If you wanted to focus on one unit, polynomials would be one to make sure you're hitting it out of the park. Double roots is the same as multiplicity. And in double, that means multiplicity of 2, which means it happens 2 times. Single roots means it happens 1 time, and we have our roots. Which function could represent f of x? Because there's 2, 3, 4, we can get rid of this guy because it's to the 3rd power, this guy because it's to the 3rd power. They were definitely coming for you on this bad boy because they only have 3 numbers up here. Again, multiplicity of 2 means it happens twice, so that's 2 roots, 3, 4 roots. So now we have to either choose between A or B. Your choice. You can write these factors, which x equals 1. If I move the 1 over, I have x minus 1 as a factor. X equals 3. Move the 3 over. X minus 3 is how I would have gotten the solution of a positive 3. The fractions is where guys are still messing up. -1 over 4 equals x. To get 4 out of the denominator, you're going to multiply, and that's going to be 4x equals a -1. Then divide. We're moving towards 0. Add 1. So 4x plus 1 is going to be our factors. These are our 3 factors. It's a multiplicity of 2, which means it's going to happen twice. You can square it or you can write it 2 times. And then you're going to box method or FOIL to get that answer. I already did that math. If I can find it for you, it does take some time. Again, so showing where the factors came from and then working my way down. And then we come up with the final answer, cleaning out our box. And that's 1, 2, 3, 4 factors to get here. Other option, if it happens to be multiple choice, like I said, don't count on it. Not enough to make me comfortable, to be honest. So the multiplication is something you definitely want to try to do. I will upload these answer keys for you and send them out later. But if I plug these two in the calculator in Desmos, and which was on this page I was telling you not to pay attention to, get rid of this one. These are the two answer choices that we know are options because they're to the fourth power. We know the double root, single root, single root. If I graph the first one, it has a single root at 0.793 and 4.171. Really nasty. Because remember, we have one at 1, 3, and a double root, so a bounce. We definitely have a bounce here, but it's not on the x-intercept, so it's not a solution or root or a 0. Now, I have a solution at a negative 1/4, negative 0.25, just as another call out, negative 0.25. If we don't know off the top of our head, that's 1/4. Any decimal, I shouldn't say any. There's a handful that this will mess up and won't help you much. But most nice clean decimals, if you hit the squares over the division sign, it will turn it into your fraction that we were looking for. So we definitely have a 0 at negative 1/4. We have a 0 at a positive 1 and a 0 at a positive 3. And the only difference was our x to the third power number, and it is negative 56. So the answer for that guy is B. Not a hard problem in theory. If we know that multiplicity of 2, I think is the only place you could have gotten big mixed up. Because if you know multiplicity of 2, you know there's 4 roots. Get rid of 2, plug the other 2 in Desmos, rock and roll. If it's not multiple choice, again, then you're going to have to go through and multiply these. As a list, I know I said it. I just don't want us to mess up. 4x plus 1, 4x plus 1, that's multiplicity or double root, happens twice. X minus 1 and x minus 3 would be all the things that you will multiply. Fun, that h of negative 1 is getting good. That's inverse functions. Yay, everybody loved those. That's just the opposite. That's where we switched the x and the y when we had to solve for it, and then we isolated y. And we're used to isolating y, but it's the switch part, and then sometimes the actual algebra that people have an issue. They don't give us an equation. They give us a coordinate. Inverse functions, remember, it is a switch of x and y, which means that the original function, so h of x, passes through 211. That's 211, so that's our x and our y. The inverse is just going to flip those two. So your table would flip them. And that's all you can do for this equation to figure it out. Now, you can either go in and plug in 2 and 11 and flip them backwards. So 11 for x, 2, and make sure you get 2 as your output. So like if I take this one, 3 times 11 plus 16 divided by 2, is that going to give me 2? Hopefully you know 3 times 11 plus 16 divided by 2 is definitely not going to give you 2. Way too big a number at the top. We can try 3x minus 8 still. 3 times 11 minus 8 divided by 2 is, I feel like it's still going to be way too big. That's 33 minus 8, which is going to give me 25 divided by 2. Still not giving me an output of 2 that we're looking for. 2 times 11 minus 8, so 22 minus 8 divided by 3. 22 minus 8 is going to give us, oh, can't do the math in my head. Why did I not write all this math down? Sorry. 22 minus 8 is going to give us 14. Cold medicines have made me extra sleepy. Yep. So we're going to get 14 divided by 3. That is a problem because I think I saw that the answer was D. Let me go check. It is D. So I've done something wrong. I will come back. I owe you one because 2 times 11, 22, our x value. I hope there's not a typo. I'm sure I'm doing something silly. Like I said, I've been on cold medicine. If you see it, by all means, email me. If h of x passes through, what choice would be the equation of h of negative 1? And that means they would flip. X has to be 11. the output would be 2. 2 times 11 is 22. Minus 8 is 14. Minus 16. Hello. Found it. Sorry. Blind moment. Minus 16. I was reading the top one. If I take 16 from 22, hopefully I'm going to get 4. I get 6. Yeah, sorry. 6 divided by 3 does indeed give me 2. Thank you for putting up with me. Like I said, sorry about that. So as long as you copy your problems correctly, make sure you're focused, you should be good. Our answer would be D. And again, this is correct. Our given to the inverse. Also, this case you didn't get 2 equations. If you get the 2 equations, graphically, they are going to reflect over the y equals x. And that's the perfect diagonal line on a graph, the 1-for-1 diagonal line. So whatever is on this side is going to be opposite on the other side. So this is going to, in its inverse, be right here. Let's see another good point. Like 0, 5 should be 5, 0 in the inverse. So this would be your inverse of the graph that's given. It should mirror over that fold as well. But again, depending on how your brain works, this is 0, 5. You just switch them. The inverse is going to be 5, 0. This is -1, +1. The inverse is going to be +1, -1. XY flips for inverse. Now, for this one, we've graphed 4x plus 5, started at 5, raised 4, run 1, down 4 to the left 1. It is a positive graph. So it's a beautiful graph of that one. What is f of -1 to the 1? Remember again, that -1 does not mean the same function here. This is the inverse of the function here. So when we plug in, we're looking for the y value that's a +1 in the previous. That's going to give me what is the x value that gave me a +1 in the original function. So you could either look at the graph and go see at +1 what the inverse point would be if you're a visual person. Algebraically, again, this was the y value in the original ones. So it'd be 1 equals 4x plus 5. I'm going to subtract 5 from each side. -4 equals 4x. Divide by 4, divide by 4. -1 equals x. Because when x was +1, to get an output of net +1, it was x was -1. So again, when you see inverses where we're used to this being the x value in a regular function, the inverse, this is the y value, but only for inverse functions. So when you see that -1, also that -1 will not go into delta. It does not know what you're talking about. I'm sorry, Desmos. It does no idea what you're talking about. That -1 will make it 100% shut down. Last but not least, we'll call it time. The surface area in square inches of a melting slab of ice after t seconds is represented by this function. A big thing looking through lots of EOC questions in the last couple of days is making sure you understand what this function is saying. And it tells you, but it's words. So surface area, that's going to be the output. That's our y, right? So when we're done, we're solving for surface area in the given function. T in the given function is going to be time. How long are we tracking it? Looking at this ugly guy, don't panic. Just know that the output is going to be surface area and we're tracking it for some amount of time because they told us seconds in this case, right? So what is the meaning of S of -1 of 20? Again, like the last one, we see a -1. That means this is the output of original function. So it is the y value. Our answers are not asking us to do the math. So we just have to understand that the output is going to be surface area. So the surface area of the ice after 20 seconds, if you misunderstood this to now be the x value, because if this was S of 20, it would be the x value, or seconds, the t value, but it's the inverse of such. So it's not the surface, seconds, it is the surface area. So this guy's out. The amount of surface area has decreased after 20 seconds. I'm assuming decrease came from that -1, but that's making things up again. This is a terrible answer if we know what we're doing at all. The number of seconds required for the surface area to become 20 square inches. So at least now we're talking about that the surface area is 20 square inches. because this is our y value, right? And last but not least, the number of seconds required for only 20% of their original surface area to remain. I think they're playing with you again. That 20% makes no sense to this problem, discussing it written in function notation. And there's no conversation about percentages. If you remember in exponential, the percentage is inside the parentheses anyway. So maybe A and C you could get mixed up without, if you're just using common sense in like how logical the answer choice is. Obviously, this could only be a multiple choice question. Don't talk yourself out of good answers. So number 9 is C. All right, guys, I will see you next week. Hopefully we're all better.